Start recording. We had done identification of components of the motherboard. Hopefully all of you are well familiar with components on the board. Are you? Yes. Can I, Ibrahim? With some. Y- you're supposed to be familiar with all those components so that it becomes easier. Pardon? Okay. So maybe let me ask one question. Is this one visible? Someone can tell me what this is? This one, eh? This one, eh? What is that? This is a transistor. This one? This is a diode. This one? This is an IC. That's a nice one. Then this one? This is a connector. This one? BIOS chip. Okay, fine. What is this? That's amazing. This one? There is a pad. What else? Then I think we are all set. So we didn't finish yesterday's business. Actually, that included identification, how those components should be connected on the board. Let me bring my okay. So we have we'll start with the most common one, which is a capacitor. I think we've been told that this is an electrolytic capacitor, right? This one. It is labeled C. Yes. So this is a capacitor, right? So we have a few things. Number one, you should know that what is written on the cup here is what we call the part number. Anything that is written on the chip, like this one, this is the part number K27E, then that 3. We have the SIO, the EC chip here. This is the part number. I don't know if it's big. So this is the part number. Let me zoom it out a bit. This is a Nuvoton company. Pardon? A part number is an identification number. It's like your ID. Yes. Part number is just an identification number. So this one identifies what chip this is. This is written Nuvoton. Let me try clean it. I don't know if it is written Nuvoton. Is the writings visible? Writings are visible. So that is written Nuvoton. That is Nuvoton NPC E586H A0MX. So Nuvoton is the company that has made this chip, right? Just the same way, Windbond here, That is the company that made this BIOS chip, is a Winbond company. So what usually happens is HP as a whole is going to outsource components. They come up with the design of the motherboard, then they give it to another company for assembly, right? Assembling this motherboard, that is soldering all these components and so on and so forth. So this one is a Nuvoton NPC E586HA0MX. This is how you identify when you want to replace this chip. It must have the same part number, right? Figures like the 66AFB is not so much important because, as I told you, these ones signify the dates at which probably the chip was made, the line at which the chip was made, and so the most important thing is this one, the NPC, this number. When you're doing a replacement of this chip, that is what you check. So okay, same to this one. Would say this one is the part number of this, the Infineon. Yes, someone is rated his house. All right. Yes, what matters so much is this part number. Okay, what you should understand is that not only this motherboard uses this Nuvoton chip, several motherboards use this Nuvoton chip. So long as any motherboard with the same part number, it can be used. So long as this part number is same, that is the most important thing when doing a replacement of this chip. Yes, yes, of course, most of this, that one we'll learn when we'll be doing the KBC section, that is keyboard controller stroke the SIO. We learn everything about this chip. Of course, most of them have the software that is controlling them. Most of them, most of the chipsets, not only this one, even the CPU, even the GPU, the PCH, all of them have low-level softwares. We call them the low-level softwares. They're basically written in binary. Is there another question? Any other question? Okay. So that is all about identification. So the basic things, how a capacitor is connected, let's start with that. That is what we were talking about. So this is a capacitor, right? So one side of a capacitor is usually connected to the positive, and the other side is usually connected to ground. Okay. Hopefully all of you know how to use multimeter. Let me not assume. You people know how to use multimeters? Yes, Vincent. Mm-hmm. 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 Mm. Okay, fine. Anybody who does not know how to use a multimeter, probably I'll do a video, or maybe tomorrow During the day you can look for me before the class. Is that okay? All right, thank you. So one side is usually connected to the positive and the other side is usually connected to the yes. Somebody has raised his hand. Mm-hmm. Mm. On the multimeter. Mm. Okay. Okay. It's okay, fine. Then if we'll just have to do it now, because if we miss it, okay, two of you have raised the question, so we'll just have to do it. I feel that if we miss that, so we have, I don't know whether it is well visible. Is it? So we usually have two types of multimeters. We have the manual multimeter and the automatic one. I used to have a manual here. I don't know if I still have it. Okay, I don't know where it is. Probably I'll look for it. So this one has both manual and automatic. Yes, Vincent. Mm-hmm. 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 Continuity and voltage. Mm. 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 Okay, that is what we want to learn. I feel I should not postpone this one to the next class. If you don't know how to use a multimeter, that's a very basic tool that you'll be using. So we have a couple of things to be measured. Number one, we have the current, we have capacitance, we have voltage, we have continuity, and we have the diode mode. Of course, this multimeter has a capability of measuring temperature and hertz, but those are not so much important. Hertz is the frequency. So turning, it has something for, I don't know how I can call it. In electronics, it's called the what? The tuner. Yes, the tuner for turning to whatever mode you want. I guess all of you have such a thing, eh? In your multimeter. Ibrahim, yes? Right. Mohammed? Oh, thank you. So this turning thing, it's called a tuner. Yes. This thing here that I'm turning. Yours have it, or you have the expensive one? It has, eh? There's a multimeter that will be coming again. I'll teach you how to use it. So the first sign is this one, eh? So at this point we have, this is diode, this is continuity, and this is resistance. This is a sign of ohms. This one shows continuity, this one shows a diode. So the moment Yes, Vincent. Am I okay, Mohammed? I think it's your side, Vincent. Okay, fine. But if you miss something, probably you can raise a hand. So we have continuity, we have diode, then we have this is called ohms, measuring resistance. So the moment your knob points, we have a pointer here, right? The moment it points at this, you can measure all the three, right? Now, for you to shift from one uh, point to another, let's say you want to shift from diode mode to continuity mode, I have a button here which is called select that I press, right? Once I press it, then like now I've pressed it, the screen of my multimeter is resistance mode. I press it again, um, my I'm in diode mode. I press it again, then I'm in resistance. You can see that. Can you see that? Yes. So you can change. It goes to ohms. You change it again. It gets to diode mode. You change it again. It gets to resistance mode. Sawa sawa. So all of you can try. Can give you some few seconds. You try and see if it is changing. You are able to change from one mode to another. If you, that is, if anybody is having his multimeter. You able to change it? It must show on the screen here. Yours is okay? Vincent, you have yours? Oh, okay. Okay. Mohammed, you have yours? Can I see a pic of, if you can just show the camera, I see how it looks. Mm-hmm. All right, so that is a manual one, and for yours, let me zoom the image out. Just a minute. Okay, these are purely manual, so shift it to the diode mode, diode and continuity mode. No, no, no. Down. Let me. Where is the arrow point? Oh, good. So, what is being shown on the screen? Can you try and attach the two probes? We see if it is beeping or showing some numbers. You've attached the red and the black probe. The two wires. Why is it off? Where's the arrow on the tuner? Where's the arrow pointing? Which side of that side? Uh, I think your multimeter is having a problem. Can you go to Where can we test it? Let me see. DCV, go to DCV 200. Okay, you have any batteries there that we can use to measure voltage? You can try get one so that we do some measurements. Put one side on the positive and the other one on the negative. And we see what type of readings you're having on the multimeter. What readings are you having? What readings is it showing? 4.8. That is 4.8. 4.8. Now shift to the DCV20. Now that will give you much more accurate reading. Now let's see much more accurate readings it's going to give us. It's giving? Oh, no. Ebu connect probes vile connect sazile. .79, 4.8, 4.79. The other time it was giving us a reading of 0.4. That was ideally 4.8. So you can right now it is giving much more accurate. So what you realize with these manual multimeters, is the ranging. You must know where to put the tuner. Let's say you are doing a measurement of a battery that probably has the highest capacity of 10 volts. You put it on the 20, right? The higher side. If the source you're measuring has more than 20 volts, you put it on the 200. If the source you're measuring has less than 2000 millivolts, you put it on the 2000 M. If it has less than 200 millivolts, you put it on the 200. That is the, I don't know, is the goodness of those manual multimeters. You are able to range it. But now this multimeter of mine or any other automatic multimeter will do automatic. You don't have to range it or give it a range of probably less than 20 volts or anywhere above 20 volts to have an accurate measurement. It will give you automatically an accurate measurement. Sawa. So right now you should be well familiar with your multimeter. Is that okay, Mohammed? If you have any question, I'm usually around. Ibrahim, can I see your multimeter? Ibrahim around? Let me see. Is that an automatic or a manual? Does it have the 200 figures? That looks like an automatic. Which make is that? Unit. That's a nice multimeter. Okay, that is automatic, of course. Iko na hizo ranges 200. It's yes. I also can't see it well. So probably Ibrahim should tell us. Does it have anywhere written 20, 200, 2000 millivolts? You are muted. Mm-hmm. It has, eh? Oh, so that is a manual. Does it have an automatic feature? Okay, that looks like a fully manual. I think just the same way Muhammad's multimeter was being used. Can you try shift it to probably voltage? Let's say you want to measure 20 volts. Where should you shift the probe to, the tuner to? Let me say 21 volts. We want to measure 21 volts. Where? That's amazing. 200 or 20, okay? But of course 200 will give you, which one should is going to give you much more accurate? 20 or 200? 200. Yeah, 200. 200 will give you much more. Okay, fine. Put it to resistance mode. What's on? Yeah. Just a minute. Are they okay? Hello. 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 Am I audible? Wait. Hello. Hello. I'm audible. Sorry, I had a client. So you know how to use yours right now, eh? Try measuring resistance. OL means overload. So when you see OL means, that means the resistance of whatever you're measuring is extremely big that the multimeter cannot measure. So can you attach the two probes together? We see the resistance. The resistance is just attach them 0.0. Yeah, 0.0. So that means there is an absolute connection between the positive and the negative. So that is how you get the resistance, huh? Yeah. So any other question? I think we've checked the voltage. We've checked. Iko sawa? Yeah. So in case of anything related to camera, you can give me a call. Eh?
Okay. That's noted. But I'm hoping nothing is going to come up.
It's a relatively new machine. Nimeona iko mpya, iko sawa.
I didn't sell it to her a long time ago.
Iko sawa, iko.
And then I have an 840G4, a Core i7. It lost one day. I woke up and started it. It did not start. Then the power indicator ya power na caps lock ilikuwa na blink continuously mara mingi, so nikapeleka kwa fundi. Akaangalia akapata motherboard ilikuwa na issue ya power. Akatengeneza. I picked it up the next day. It worked for like a week. And after a week,
ikaleta same issue. Ni model gani?
840G4.
G4.
Yeah. Same problem again reoccurred. Although he told me, according to the way he saw it, in case he showed the 10, he replaces.
You can sasa, bring it.
Sasa nikaiweka tu kando. Nikasema, hey, sasa.
You can bring it. You can bring it to check it out. Where the problem is exactly.
You see where the problem could be.
You'll use send money. Oh?
I use send money?
Send money is okay.
Sasa, I'm going to do, I think 2 transactions. So
it's okay.
I have money in mobile number. 07
96 24 76 45.
07
96
Mhm.
24
24
76
76
45.
Barak.
Message.
Nimetuma 21.
21, eh?
Sasa 1000 then.
Right. Sawa sawa. Thank you so much.
Asante, nashukuru pia.
Takupea warranty ya miezi 3. Warranty, I give warranty on repairs.
Ah.
Yeah. So in case of anything related to that camera,
Eh.
you just bring it back, I'll do it for free.
Sawa.
Yeah. Aye. Hello. Poleni sana. Sorry, I was giving a client his machine. Right. So resistance. Once you shift it to the resistance mode, you just measure whatever you want to measure. Let's say you want to measure a resistor. So you can get direct values of the resistor. Which resistor can I use to measure? We'll use the current sense resistor. So it should be, where should it be? This current sense resistor is a type of a resistor used to sense current. This one. So you can check the resistance, and the resistance is 0.7. So has a resistance of about something nearly 0. So that is how you measure resistance. Measuring that, yes. Reframe the question. What component do you? That is a resistor. This one, this is called a current sense resistor. It is used to sense current across the charging circuit, right? Again, we are going to learn about it. That is ideally what we were to learn today. You can see down there put charging circuit versus the input circuit. But then, since because you didn't know how to use multimeters, I have to prioritize that because okay. Is there any other question about? I think diode mode. Diode mode. How a diode works? It diode does what? A diode inakataza moto ku go into the reverse side. That is current can only flow from one side, so it can't allow current to flow the other side. So let's say, and if you're having a sample diode here, yes sir. Okay. Oops. I'm sorry. We were looking for a diode. Where's the some? I'm looking for a Zener diode that will make it easier for us to understand how a diode works. That's a two-legged diode. With the capacitor. Hey. I'm having people disturbing us. I'm going to look for a diode. Vincent is out. It's okay. What else? I think the diode issue. Let me see. The problem with a three-legged diode, we will have to get the schematics, which we currently don't have, to see how the current should be flowing from what side to what side. But ideally, shifting the probes from one side to another should be able to show different readings, right? I'll get a diode we can use to elaborate that for well. So is that okay? So is there any other thing about the multimeters so that we can check out what we need to know? Capacitance, you just you shift your, this means capacitance, so unaiweka hapo sawa. You see the arrow pointing on the capacitance. Then before you measure capacitor, the number one thing you do is to discharge the capacitor. So you will come like to this capacitor. How do you discharge a capacitor? You discharge capacitor by connecting the positive and the negative, and you exclude all the sources of power. So attach it like that for some few seconds, and you completely discharge the capacitor. Good. Then you come with your probes, one side and one side here. Then we get a reading. Let me show you the reading. We are getting a reading of still loading. So it has shifted above here to millifarad. We have microfarad, we have millifarad, and we have farad. Farad is the biggest. Then we have millifarad, then we have microfarad. What is the problem? Yes, yes. Mm-hmm. A dead capacitor. A dead capacitor usually you just is just a shorted cap, right? If you measure the resistance from this side to this side, I'm not showing the board. If you measure the resistance from this side to this one, and you see the resistance that is very low, then you know that that is a shorted or a dead capacitor. You should not have beep between one side and one side. So at the resistance, yes. Resistance or continuity, both of them measure the same thing. Yes. So if you put it in a beep mode and you attach both sides, and you see it having some having a beep or a very low resistance, or probably 0.0 something, then you know that that is a dead capacitor. Inductors, they are used to store energy, and if you measure the resistance of inductor to ground, you should not be getting any reading, right? So but if you connect both sides, you should be getting some readings. These ones, you should be getting a very low resistance. Beep mode, you can hear my multimeter beeping. So that is how a good coil should be behaving. But if you measure this one to ground, it should not be beeping. Usually they are connected on the positive side, so this one should not be beeping, right? Like that. Is there any other thing? Resistors, we are done with that. We're going to learn about the ICs. MOSFETs, you know what a MOSFET is? Oh, do you people know what a MOSFET is? The working principles of a MOSFET? Normally it behaves like a what? Like a switch, eh? They're called the switching MOSFETs. They have the source, they have the gate, and they have the drain. So for instance, this one is these are two MOSFETs in one, because we have two source, we have two gates, and we have one drain. We have a gate here, we have a gate here, we have source here, and we have drain. Yeah, but it's having two gates, so it's called a dual MOSFET. Same to this one, is called a dual MOSFET. A single MOSFET should be having one gate. This one is having one gate. This is having one gate, one source, and one drain. All these four pins are connected together. You can test. You can see they're connected together. All these three are connected together, but this one is not connected to these three. So that's how. Are we going to learn about the input circuit. We have about 24 minutes. I don't know whether that is going to be enough. Should we just start, then we finish the rest tomorrow? Okay, fine. So the main thing we have to learn today is called the input stroke the charging circuit. So Vincent was asking me that he wants to know how power flows on the motherboard, and power flow starts from the input circuit, that is from the power jack. Here we're having the power jack where you plug in your adapter, right? So we're having the power jack here. Is it visible? This is what we call the power jack. There's a diagram I sent on WhatsApp and some notes. I told you we are not going to probably be doing notes. There's a diagram. There's a diagram, one document with a diagram. Shows the architecture of the input stroke charging section. Can all of you open it? It's going to guide us a little bit. So in almost all the motherboards with the traditional power jacks, what I mean by traditional power jack is that it is not using a type C. So any board with a traditional power jack, there are some which have the dual mode, that is uses the traditional and the type C. We have example the 840 G5 series, G6 series. They usually have the type C and the traditional jack. So from here, from the power jack, we usually have what we call a fuse or a low carbon resistor, and we can trace it. It's very easy because you trace the track from the positive, right? Here we have ground. Here we have an enable pin. These ones are ground. So if we shift our motherboard to this other side, we will get the positive side, and this one is the plus. Okay, and if you can see it, we have the plus here. The plus runs from the power jack here. It gets into a low carbon resistor. This is a low carbon resistor, right? So if we continue tracing it, it gets onto the other side of the motherboard. We can shift again and see where it goes to, and it comes here, right? So are you able to see it well? We are following the track. You want to see the flow of the motherboard from the input jack. So from the jack, it went to the other side, it went to a low carbon resistor, then shifted onto this other side of the board. Is it visible? Are you following? Eh? I start from the jack. We're having the power jack here. This is the power jack. This is where we plug in. This is where we plug in like that. So Yes, Vincent? Okay, it's okay. There's no problem. Okay. So we're having the input, we're having the jack here. I think from the diagram you can see that from the jack it goes into a fuse or a low carbon resistor. See, mnaona from this is the track. Hello? I think my mic, the battery of my mic was yes, my mic ran out of battery. So from here it gets here. If you see these small holes, that means it's going to the other side of the motherboard. You can clearly see there is nowhere it is going from here. Okay? Yes, yes. Mnanisikia? Here we have the power jack. Here we have the power jack. Let me, I cannot get a wider view than this. Okay, let me just show you what we are working on. Here you have the board, Sindio. Here is where we are checking. So here you have the power jack. Sawa. Iko sawa. We have the power jack. Now let's zoom in using a scope to see what we are dealing with. From the power jack here, we have the power jack here, right? Sindio. Hope you can see it well. I think what can I do so that you understand this well? The diagram I sent, do you guys have it? Let me see if I can display it on the screen. We do some comparisons. Screen is visible. Is the screen visible? Enable editing. Zoom it out a bit. Is that visible? Hello? Can you see the screen? So we usually have the DC jack here, the DC connector. You can see from the diagram, Hopefully you can see from the diagram. Hello? Am I having a problem? Can you see my screen? Am I having a problem with my internet? No, I might be talking alone. You can see, very well, not that much. You can do reference with the document, on WhatsApp. So we're having the DC jack. The DC jack is usually connected to a fuse, an input fuse, or usually what we call a noise filter, EMI, or a combination of all these. The input fuse, the MEI, noise filter, and the surge protection can be bypassed by any. That includes a fuse. That means you can have a DC jack then directly connect to an input fuse, or a DC jack direct connect to a noise filter, but not a diode. So we could probably be having any of the three things: a noise filter, an input fuse, or a low carbon resistor. This is just a connection from the DC jack onto the back-to-back MOSFET. That is the PQ1 and the PQ2, first MOSFET and the second MOSFET. We have two MOSFETs in the input circuit that does regulation of power input onto the motherboard. And as I told you, a MOSFET has the gate, the source, and the drain. So the gate and the gate is usually connected to the charging IC, goes direct onto a BQ chip or an intercell chip, or the charging chipset. Again, we are going to learn about that. We could probably have not enough time for the same, but I promise we should be doing a detailed architecture of this input circuit and power flow up to the charging section. That we'll do tomorrow. So probably this is just an introduction because we've spent much of this time working on the other things. So from the two MOSFETs, we should be having what we call the current sense resistor, the PR1, which is usually something below, something nearly zero. The resistance should be nearly zero for perfect performance. Then from there we're having the main adapter rail. That is probably where we'll be getting the 19 volts, and that is what goes directly into the system. Now, why should you learn about the input circuit and all these capacitors? Number one, if you're having a problem with the input circuit, your machine will probably not be charging. Your machine will probably not be powering on completely. That is, if you're having a problem with the power jack or the first or the second MOSFET or the current sense resistor, your machine will not be having any power, right? So you must sort out the issue first before you proceed. Again, we are going to learn and to see, we are going to follow voltage in real sense in tomorrow's class. Voltage from the DC jack up to the main power rail. We are going to see all the connections from the first and the second MOSFET to the charging IC. We're going to see all the connections, how it proceeds from the main power rail up to probably the 3.35V. That is another section we will not be learning tomorrow, but we'll be learning it on another day. We are going to see how the charging IC works. We are going to see all the signals that are running from the charging IC, that is controlling the MOSFETs and those that go directly onto the CPU, what type of communication they have, what type of voltage they should have for for proper functioning of the motherboard. So an input circuit is quite an essential part that we'll have to extensively check tomorrow. I think I'll give you time to go and check out this document, this picture. You see how it works. Remember, this is just one in a few, but we're having so many resemblance. We'll be having the Type-C architecture as one of the input circuits, which is much more advanced than this. So please, I'm pleading with you that we should be able to understand this very fast, so that if we have a machine that is purely Type-C, like this one, I don't know if you can see this. See, such motherboards, the 1030 series, they have no power jack. All of them, they just use Type-C ports, all right? So this is much more complex than this. So let us just have a full understanding of this, because majority of the machines are using this architecture. But then the current generation machines are using the Type-C fully. So go and check out the document. I think it's around 723. Then we'll learn extensively about the charging circuit tomorrow, if that's okay. Is that okay? Yeah. Please check out the document. I don't know if I can prepare something that is much more visible and easy to observe. I'll see before tomorrow's class. So just allow me to end the class, then we finish tomorrow. Sawa sawa. Alafu, before I end, any of you with probably a shop? Vincent is having a shop. So yeah, that's really amazing. Please start taking in jobs for motherboard repairs. Mohammed, I don't know if it's very possible. Just start taking as early as now. I'm here to guide you. If you find any job related to motherboard repairs, you can usually take in the job, talk to the client to leave you the machine. Then where possible, I can guide you what to check. Start as early as now. Don't wait to finish the course, then you start doing the same. Sawa sawa. Yeah, so if you have any question, any concern, you can call me. When I'm busy, I'll tell you, probably call me in an hour or so. When I'm not, we can usually check out all those things together. Sawa sawa. Same to Ibrahim. Vincent, I think Vincent has been keeping me a little bit busy. Today he was doing programming for a machine, probably just for testing in his shop, and he had to call me, and I sent him some files. So you must be very proactive. I think we have a lot of time during the day that you can do your own things. Once you have a motherboard, unaweza chokora uangalie. I'm here for any question, for any assistance. Ukihitaji, just call me, just text me. I'll always respond. Sawa sawa. Sawa. Let me just end the class. Hello, Stanley. Hello. Hello. Stano. Pole pole pole. Nilikuwa mahali siwezi shika simu. Sijatoka, natoka nayo saa hii. Sijatoka bado shop, ndio natoka saa hii. So natoka nayo nikikuwekea. Natoka natoka nayo saa hii nikikuwekea. Pole pole. Natoka nayo saa hii nikikuwekea. Sijatoka shop ndio nakupigia unaweza kaa ni sawa sawa. Bosile, utaki watu wakupigie simu? Utaki? Utaki maneno mingi? Hello? Hello? Yes, yes. Imeletwa hata ndio imefika sahii, hata sijui tutafanyaje. Niko hapa shop tu mahali mlikuja, so ubaya huku kunafungwa around inafaa ifungwe by around 7:30. Naweza kupata wapi? Tirum. Aha, hebu kuja, si unajua ile shop tulikuwa ile siku. Aha, sitafanyaje? Ni Kone shopping mall. Kone Kone KOONE. Hello. B10. Hello, bosi.
Yes, daktari.
Niaje?
Poa sana.
Uko salama?
Niko chonjo na wewe?
Niko chonjo kabisa. Okay. Mashini imekuja hapa hata haijakaa sana. Okay.
Bado unaendelea kuzitibu?
Sasa ni kuzinini tu mdogo mdogo huku. Sijui kama kuna moto ya kutosha. Acha. Tunaita nini? Aya, unaweza kana hapo uicheki. Hello Stanley. Oh, ile location tunaandikanga wapi? Karatina, sawa sawa.
Hauna yenye
ni
refurbished? Si hii yenye imetumika.
Hiyo ni refurb.
Hii ni request ya mtu. Anataka kakitu kanakaa hizi refurbished. Unaona kama hii.
Anataka yenye iko nini kabisa?
Sasa kenye uko nayo.
Sijapata yenye iko safi sana. So hiyo probably mpaka kesho.
Juu huyu pia atakuwa tricky.
Mpaka kesho.
Kesho tunaweza pata.
Kesho tunaweza pata. Sasa saa zingine ni bei tu inatu nini. Sasa hii hata tunaweza pata hiyo ya 24500 tunaweza pata hata sasa hii. Sasa unajua bei ndio. Hiyo tunaweza pata hata sasa hii. Hebu tuone kama Hello? Niaje? Hello? Nini G3? 840 G3? G4. G4 iko safi? Oh. Bunione kidogo nikwambie. 840 G. Sawa. Hebu kidogo nakupigia. Hebu niletee hiyo G4.